Okay, the structure of a proof is very formal. Some things that we don't do a whole lot of is, for example, if 3x equals negative 18, then x equals a negative 6. The if part is called the given, and the then part is called the prove. So what we will often see is it'll jump right to the actual formality of the proof and just write it as given. 3x equals negative 18. Prove x equals negative 6. Proof, meaning that what's following is going to be your actual proof. When we get into geometry, you will have a diagram here. And then when we are proving it, you're going to have two columns. You're going to have a statement column and a reasons column. Now, there are different types of proofs. I think as a math department, we have adopted that we prefer the two-column proofs. There's also one that are called paragraph proofs, and there's also flow proofs. Okay, so when we have statements and reasons, when you are numbering, make sure that your numbers are lined up. So what I don't want to see is like statements 1, 2, maybe this one's a little bit longer, 3, 4, and then off to the side in your reasons that they start getting numbered off. I want them to be exactly straight across from each other, okay? Oopsie, a little bit of a pet peeve of mine, okay? So statement number 1 is going to always be whatever your given is. So 3x equals negative 18. Your first reason is always going to be given. Okay? If you have, when we get in geometry proofs, you're going to have more than one piece of given. I'm not a big fan of putting all the given in one statement. I'd rather have you use it as you need it. So you might see reason number 1 is given, reason number 3 is given, maybe reason number 4 is given. Okay? When you're doing an algebra proof, your work that I would actually be applying the properties to is not part of a statement. So if I want to solve this, I'm going to divide both sides by 3. What I get when I clean it up, x equals negative 6. So what I get when I clean it up, that is my statement. So the work is not part of a statement. I'm going to put my reason number 2. So what you have to look at is, what did I do here to get to here? That is my reason. So here I divided both sides by 3, and I can do that because of the division property of equality. Your last statement, your last statement better be what your proof is. If it isn't, then you have not proven what you need to prove. So these had better be the same, identical. Okay? Let's do another example using some algebra proofs. Ones that are a little bit more difficult. So if I have given that 10m minus 4 equals 2m minus 20. I want to prove that negative 2 equals m. And I purposely did that backwards so we have an extra step in there. Okay? So there's my given. This is my proof. I'm going to write the word proof because that's telling me I'm getting ready to do my proof. I have my statements. And I have my reasons. Statement number 1 is always a piece of the given. Got to have some place to start. And my first reason is always given. Now I'm going to, like with a pencil or a different color, I'm going to figure out what I want to do. I'm kind of partially getting the variables all together first. So I'm going to go ahead and subtract 2m on both sides. When I clean it up, that is my statement. So I have 8m minus 4 equals, those add out, gives me a negative 20. Why can I do this? I can do this because of the subtraction property of equality. I am subtracting the same value on both sides. Okay. Next, for my other piece of work, I'm going to add 4 to both sides. Remember, when I'm talking about both sides, I'm talking about in reference to the equal sign. So what do I get when I clean it up? I have 8m. Those add out, equals, and I get a negative 16. Why can I do this? It's the addition property of equality. My next piece of work, I would be dividing both sides by 8. Why can I do that? Because of the division. Oopsie, let me clean this up first. M equals negative 2. Why can I do this? Because of the division property of equality. And any example or any abbreviations that you see me using, feel free to use as well. Now, a lot of people would stop here and say, hey, I'm done, but you're not, because this is asking for negative 2 equals m. We have m equals negative 2. We actually have one more step, and that is to switch these two around. Negative 2 equals m. Why can I do that? That's that one we talked about called the symmetric property. If you are done and you know that your last statement matches your proof, which it does, I was always taught to put these 3 dots in a triangle, means therefore, so it tells me that you are done with a proof. So these are 2 examples of algebra proofs. Geometry proofs have a little bit more detail with them, but this really gets you thinking as far as why can you do things, and you can't do them unless you have a reason that you could put over here. If you don't have a reason, then you got to go a different way.